A picture of a three-dimensional wave and can see that water waves travel in straight lines from the source, just like 2D waves do. If I attach a small spherical ball to the source, I can also create circular waves in the water. Notice these waves also spread out from the source along straight lines. Now let's use the ripple tank to see if 3D waves behave in the same way as 2D waves when they reach a boundary. You should remember that a 2D wave can either be reflected or refracted when it reaches a boundary. If the wave is reflected, it will always obey the law of reflection, which says that the angle of incidence is always equal to the angle of reflection measured from the normal. Refraction takes place when the speed of the wave changes as it enters a new medium. This change of speed will cause the wave to bend if it meets the boundary at an angle of incidence greater than 0 degrees. Let's see if a three-dimensional wave can also be reflected or refracted at a boundary. Have a look at what happens when a barrier is placed at an angle to the wave front in this tank. Can you see the places where the shadows crisscross each other? This shows that the wave fronts have changed direction after striking the barrier. In other words, the wave has been reflected. Now let's see if a water wave can also be refracted. I'm going to put a piece of perspex in the ripple tank. The water is shallower above the perspex and deeper where there is no perspex. Watch what happens when water waves move from deep water into shallow water. Can you see that the distances between the shadows have decreased? This means that the wavelength has decreased.